This is Mr. Gillum, and today we're going to start reducing fractions. By the end of this video, I hope that you can write a fraction in simplest form. Let's start with a little vocabulary like we usually do, and just so we're all on the same page, the simplest form of a fraction is a fraction that has both the numerator and denominator that share no common factors. And so what we've been practicing is equivalent fractions so far. So if I had 10/16, and I'm looking for equivalent fractions, I know that there's two things that I could do. I could multiply the top and the bottom by the same number and get an equivalent fraction, 20/32, or I could divide the top and the bottom by the same number and get 5/8. Okay, those are both, so we talked about that would be an equivalent fraction. This would be an equivalent fraction. Okay, and basically what we're going to do to get the fraction's simplest form is only use division. Okay, we're only going to use division to do that. And we're only going to be able to use division until we find all the numbers that they share, both the numerator and denominator. We use up all the numbers they share in common, all their common factors. And so some of the things that are going to help us with this are the divisibility rules that we talked about. We talked about the rule for 2, if they're even. The rule for 3, if we add the digits and their sum is divisible by 3, then that number is divisible by 3. We talked about 4s, just looking at the last 2 digits of a number. We talked about 5s, if it ends in 5 and 0. We talked about 6, if it follows the rule for 2, meaning it's even, and it follows the rule for 3, which its digits add up to a number that's divisible by 3, then it is divisible by 6. We talked about 7, how it's really the best way to tell is just using long division. 8 was the last 3 digits, and then 9 was the same rule as 3, except for instead of being divisible by 3, had to be divisible by 9. Now, that was a lot of words that I just said there. Remember, use the chart in your binder. Okay, that'll help you to remember which numbers are divisible by which numbers. This, step 2, is just by finding equivalent fractions using division. Okay, division is the key. Instead of making the fractions bigger, the number of divisions bigger, we're actually going to divide and try to get the numbers as small as possible. Okay, once we've divided, once there's no common factor, then we have it in simplest form. And so I have 6 examples of reducing fractions that I want to go through with you on this video. Now I chose these for specific reasons. Okay. Some of us know the divisibility rules a little better than others, and so I'm going to talk about some of those divisibility rules right now. Remember, we're trying to write an equivalent fraction only using division. And so I'm going to start by just writing divide sign next to each of these, because when I'm trying to reduce, I'm always dividing the top and bottom by the same number. I'm going to wait for those mixed numbers there. Okay. And so I have some options here for 24/30. First of all, I notice that they're both even numbers. So I know that I could divide both the top and bottom by 2, and 2 would go evenly into 24 and into 30 because they are both even. The next thing I see is that I could divide them both by 3. 2 plus 4 is 6, 3 plus 0 is 3, 6 is divisible by 3, and 3 is divisible by 3. So I could divide the top and bottom by 3. And that would go in evenly to both 24 and 30. If I check 4, I know that 24 is divisible by 4, but I know that 30 is not divisible by 4. So 4 would not be a good choice to divide the top and bottom by. The number 5 would not go evenly into 24, but it would go evenly into 30 because it ends in a 0. I'm looking only for numbers that divide evenly in the top and the bottom, though. So 5 would not be a good choice to divide the top and bottom. I see that if it follows the rule for 2 and it follows the rule for 3, then I know the rule for 6 would work. It is even and the sums are divisible by 3. So I could choose the number 6 to divide the top and the bottom by. 7 is not going to go into 24 or 30. 8 would go into 24. Unfortunately, it would not go into 30, so 8 would be a bad choice. 9 does not go into either 24 or 30. And 10. Usually I stop after I get to 9, but I always like to check 10 as well. If it ends in a 0, I don't see that that is the case for 30, but not the case for 24. So I have 3 options I can choose from. No matter how I do it, I can still get to the solution as long as I continue to divide until there's nothing left in common for factors. So I'm going to do this problem 3 different ways here. First, I'm going to divide the top and bottom by 2. Okay. If I divide 24 by 2, I get 12, and if I divide 30 by 2, I get 15. I'm going to try it with 3. If I divide the top and bottom by 3, I could have 8 over 10. Or if I divide the top and bottom by 6, I can get 4 over 5. I want to show you what happens when I choose each of those different numbers. When I chose 2, what I notice here is that 12 and 15 still share a common factor of 3. So this is not in simplest form yet. I have to do another step. Divide by 3. And that would leave me with 4 over 5. 15 divided by 3 is 5. Again, with the 3's, I still see that, hey, 8 and 10 are even. That means 2 must go evenly into both of them, so I need to continue and divide by 2. And again, there's my 4 over 5. There's no factors that 4 and 5 share in common. But on the last one here, I already have 4 over 5. And so what I conclude is the biggest number that I can find that they both share, or the greatest common factor that they have, would be the best number to divide by. So a real quick reminder of how we could find the greatest common factor if we didn't know through mental math would be to draw a little number tree. That's right, boys and girls, you guessed her, little number tree. If you would like to only have one step when reducing your fractions, but maybe your multiplication facts aren't quite there yet, I see that this prime factorization would be 2 times 2 times 2 times 3. If I checked 30, I would see that that is 10 times 3. There's a prime. 5 times 2. Its prime factorization would be 2 times 3 times 5. I see that they share a 2 in common. I see that they share a 3 in common. Oop. So I know that the greatest common factor would be 6, and if I divide by the greatest common factor, I automatically have the fraction in simplest terms, in simplest form. Okay. Now you may have already known that 6 was the greatest common factor and using mental math, but if you didn't, then the factor tree and the greatest common the prime factorization would be a good way that we've practiced before in the past to find the greatest common factor. When I look at 10 and 15, what sticks out to me is that they both share a 5 in common because the top number ends in a 0 and the bottom number ends in a 5. So I'm going to go ahead and immediately, it sticks out to me because I'm a math teacher that I notice that 5 goes evenly into both of them. 10 divided by 5 is 2. 15 divided by 5 is 3. And in this case, there's only one division to do to get it to simplest form. There are no common factors besides 1 between 2 and 3. Looking at 14/4, I see that they're both even numbers. So that's one thing I could do. I could divide both sides, both the top and the bottom, by 2. I could try to find a bigger, greater common factor. Because 4 is such a small number, I know its only factors are 1, 2, and 4. And so I know 2 would go into 14. 1, 2, 7, and 14. I know that 2 would go into 14, and that's the only other one. So in this case, my only choice is to divide by 2. 2 over 2, I should say. I'm really dividing by 1, which doesn't change the value of the fraction. That's why this is all legal, and that's why the fractions are equivalent, because when I divide by 1, I'm not changing the value of the fraction. I'm just changing the number of divisions in the fraction. So in this case, I would have 7 over 2. We call that an improper fraction. We learned that just a little bit ago. For Mr. Gillum's class, most of the time, improper fractions are acceptable. In some cases with story problems, improper fractions wouldn't be appropriate, mixed numbers would be, but for exercises with arithmetic, many times improper fractions are actually going to be more useful in our equations than a mixed number. 32/42 is another one that I see might have more than one common factor. So let's think about this. Okay, I see that they're both even. That tells me that 2 might go into both of them. If I check 3, okay, 3 plus 2 is 5, and 3 doesn't go into 5, so 3 is definitely not going to work for 32. So I might as well not even check for 42. 4 will go into 32. Unfortunately, I know 4 times 10 is 40, and so 42 is not going to work because the next multiple would be 44. So 4 is out. 5 is out because they don't end in 0 or 5. 6 is out because it works for 2 but doesn't work for 3. 7 might work. It does for 42, but unfortunately my multiples of 7 go 28, 35. It skips right over 32, so 7's out. 8 works for 32, but not for 42. 9 won't work for either one, and so I'm just going to go ahead and say I better just divide by 2 over 2, or divide by 1. Divide by 2 over 2 and get 16 over 21. Now I need to again think about all the different rules for divisibility. Is there any numbers that both 16 and 21 share as factors? And through a lot of experience, I know that 16, I could write my factor list if I'm not sure, would be 1, 2, 4, 8, and 16. And 21 would be 1, 3, 7, 21. If I look closely in between those lists, I'll see that none of those numbers match. They don't have any factors besides 1, and dividing by 1 won't actually change it. So in this case, this would be the simplest form, 16/21. Okay. Some of the fractions you see on your paper might be mixed numbers. Okay. We learned how to change mixed numbers into improper fractions, but when we're just reducing the mixed numbers, it's not necessary to change them into improper fractions. I really just can leave the 3 wholes alone and just think about just the 3/9 and how it could be reduced. Well, I know 3 and 9 both share a common factor of 3, so that would be 1/3. Instead of 3 and 3/9, 3 and 1/3 would be the simplest form. 5 and 6/15. It might not be clearly obvious right away that 6/15 reduces, but it actually does. I know that if I'm just looking at the fraction part that I'm trying to reduce, I know that 3 would go into 6 and into 15. Into 6 twice, and into 15 5 times. So really, the better form of the mixed number 5 and 6/15 would be 5 and 2/5. All right, so hopefully that's a good reminder, review of reducing fractions. Again, it won't be necessary on your paper to draw a factor tree for all of them or make the list of factors, but if you want to reduce the fractions in one step, you will need to know the greatest common factor, as I showed here in the example of 24/30. If you know the greatest common factor, it'll be one step. If you just see little factors in between, you might have to divide more than once. Okay, so that's it for today. It's reducing fractions.